Factoring by grouping is just factoring out a GCF twice. In this next problem, notice how x minus 5 shows up in each term, the first and the second half of the problem. We're going to divide that x minus 5 out, and when we divide it out of the first half of the problem, we're left with x squared, and when we divide it out of the second half of the problem, we're left with a 7. Now, sometimes people say, well, where did the other x minus 5 go? Well, let's look at the problem a different way. If we have x squared times blob plus 7 times blob, and I divided out the blob, wouldn't I just have x squared plus 7 left over? Well, instead of a single variable, this blob represents x minus 5, and it only comes out and needs to show once, because when you distribute it back in, there it is going to reappear, showing up twice. In this next problem, x cubed plus 2 is common to both the first and second half of the expression, so it will factor out. And dividing it out of the first term, we have 5x left over. Dividing it out of the second half, we have minus 8 left over. Now we move on to the standard grouping problems, which basically have 4 terms. You always want to ask the question whether there is a common factor that will go into all 4 terms, but in this case there isn't, because the coefficients of 3 do not show up in the second half, and there's no common variable between these first two, so there can't be for all 4. When there are 4 terms and no GCF comes out of all 4, usually what we're going to do is split the problem in half. Each problem is a little bit different, but for the most part we'll begin this way. Notice that 3 is a common factor from the first 2 terms, and when you factor it out, you have q plus p left over. And in the second half of the problem, r is a common factor, and it can be divided out, and you have q plus p left over again. Then we see q plus p is a factor of both the first and second half of the problem. It can be factored out front, and you'd have 3 plus r left over for the other parentheses. Notice that if you FOIL this out, you will get back to the original problem. For this next problem, we look for a common GCF to go into all 4 terms. I'm thinking, okay, w's, but there's no w in this last term, and as far as the coefficients, there is no number that will go into all 4 of these. But I do note that this is not written in a descending order of exponents, so I want to rearrange those middle terms before I do anything else, because that would likely affect what's going to happen with our result, and it may make it a little more challenging for us. Now I will split the problem right down the middle and take out a GCF from the first 2 terms, which will be 2w to the third. And when I divide that out, I will have 4w squared minus 5. Then I look at the second half of the problem, and a 3 is common to both the 12 and the 15, and dividing it out, we have 4w squared minus 5 again. Then we see that 4w squared minus 5 is common to both halves of the problem, and so that will be factored out front, and we will be left with 2w to the third from the first half of the problem plus 3 from the second half of the problem. Note that the way I've written this answer is not unique. I can reverse the 2 parentheses, and even within that second parentheses I could make this 3 plus 2w cubed because addition is commutative. But we would need to have the order of the 4w squared minus 5 intact because subtraction is not commutative. Again, we have 4 terms, and I don't see a GCF between all 4 terms. And trying to group it right down the middle, I don't see anything common between the first couple of terms. So again, I'm going to rearrange these so that the middle 2 terms are switched, and rewrite this as 2c plus ac, and I automatically see a common c between the 2 parts there, plus 3ay plus 6y. Now, considering this as 2 separate problems, I can factor a c out of the first half of the problem and have left over 2 plus a. And then from the second half of the problem, I notice that 3 and y are factors and can be divided out, and I'd have left over a plus 2. Now 2 plus a and a plus 2 don't appear to be same, but the commutative property of addition says they are the same. So when I factor them out, I can choose my form, and I choose a plus 2. And then we will be left with c from the first half of the problem plus 3y from the second half of the problem. Okay, for this next problem, I do see that the middle terms are like terms and can be combined together, but I'm going to leave them as they are because I want to concentrate on factoring out the GCF of all four terms. Note that 2 factors out of each of these coefficients because everything is even. That leaves me with 6x squared plus 3x plus 4x plus 2 inside these brackets. Then I'm going to split up what I see there in half, leave this 2 out front, factor out a GCF of 3x from the first two terms, leaving me with 2x plus 1, and then factor out a 2 from the remaining two terms, leaving me again with 2x plus 1. And then notice how there's a 2x plus 1 in common. So I'm going to bring that out front along with my 2 out front, and I will have 2 times 2x plus 1. And when I divide out that GCF, I'm left over with 3x and plus 2. So 3x plus 2 will be the second parentheses. Again, in this problem, I notice that all of the coefficients are even, so I'm going to factor out a 2 and break this down to 3f squared k plus 15k plus f squared plus 5. And then, because there are 4 terms, I'm going to split this up right down the middle and do what we did in just the last problem. From the first two terms, I notice I can factor out a 3k, and that leaves me with f squared plus 5. There is no GCF from f squared and 5, but that is what we're trying to get here. So I'm going to factor out a dummy 1 as a placeholder and have f squared plus 5 in parentheses. That's a trick you need to pull out of your hat every once in a while. And I'm going to do what we did in the last problem. Leave the 2 out front, factor out the f squared plus 5, and that will leave us with 3k from the first half of the problem and positive 1 from the second half of the problem.